Okay, now on this one, we are going to have two equations that were given. So we are told that one of the equations is y equals 1 half x plus 2, and the other equation is y equals 1 half x. Now notice on here, there is a kind of a hidden plus 0 there. So that just means we still have a number there, but it happens to be 0. But that, of course, is a regular number. So it's important to make sure that you recognize those kinds of things when we're looking at these values. Now, the question is, what is the solution to this system? So what is the solution? We have to remember that anytime we are looking at this, we have an x and a y value. So we have to put it in terms of x and y. No other way to do it. And so when we're doing an x and a y value, we just take a look at where do these two cross. Well, if you notice, they look like they're parallel. We aren't 100% sure because my drawing isn't the greatest, but it's not bad. But the important thing is all I have to do is just recognize if the slope of both of them are equal. Notice that the slope of the first one equals the slope of the second one. That means they will never cross. So 1 half equals 1 half. So what is the solution? There is none. They don't cross, so therefore there isn't one. Number 5 says solve this system of equations. So what we want to do in this particular case is we want to solve them, but we can solve them pretty easily. So anytime you have an equation with only an x in it, use that one first. So what I'm going to do is I'm going to divide both sides by 3. Then I know that x is equal to 3. Remember that when we're solving a system, we're going to have an x and a y value. So we want to make sure we get both an x and a y value. Well, I've already found my x, so I'm going to put a 3 up here because I know I found my x value. And now what I'm going to do is I'm going to plug my x into the first equation because now I can solve for y in this first equation. So I have 2 times 3 minus 3y equals negative 2. 2 times 3, of course, is 6 minus 3y equals negative 2. Now I want to isolate the 3y. So I'm going to move this over to the other side. So I'm going to subtract 6 from both sides because it's added. There's a kind of a hidden plus sign over here. So I'm going to subtract them. So of course these become 0. So then I have negative 3y equals negative 8. Remember when I add two negatives, it keeps it a negative, and then we just add up the numbers. And then my last step is I'm going to divide both sides by negative 3. So y equals, now of course, when I have negative 8, of course, these 3's cancel, negative 3's cancel. And so over here, it's going to be a positive. So I already can see that because negative divided by a negative is a positive. And then I have 8 over 3. So there's my y value. So 8 over 3 would be my y value. And I would be done with the problem. Just leave it as a mixed fraction. That's okay. If you want to try to reduce it, you can, but you're not going to get extra points, and you're not going to lose points for putting that number down there. So number 6, we want to use elimination to solve this one. It's pretty straightforward to do that. Now notice we want, if we're going to eliminate the x's, then we have to have a negative 4 and a positive 4, or a negative 5 and a positive 5. So this is going to be kind of a difficult one to eliminate the x's. So let's take a look at the y's. So here we have a 2y and a 1y, but I want it to be 2 and negative 2. So therefore, I'm going to multiply the second equation by negative 2. Now, why am I going to do that? If I multiply it through, remember that I have to multiply it by every single term there, all 3 of the terms there, minus 10x equals negative 80. And then I'm just going to rewrite the first equation as it was. So the first equation I just rewrote right down there. And now I'm going to add those two together. Now you'll notice, of course, the negative 2y and the positive 2y cancel. This becomes negative 14x equals negative 70. Okay, so I have that. I've got to be careful about how I write those x's with this pen. So I have negative 14x equals negative 70. I'm going to divide both sides by negative 14. I'm going to grab a calculator, if you want to. Of course, these 14s are going to cancel. And so x equals, and we know it's going to be positive because the two negatives cancel each other out. 70 divided by 14, if I were to go through and do that, would be 5. So there's my x value. Remember, when we're trying to solve, we're looking at, especially a system, we're trying to find x and y. So I found x. Now what I'm going to do is I'm going to figure out my y value. So I just need to pick one of the equations to solve it. Now, does it matter which equation? Do I use the first one or the second one? It doesn't matter. But notice in the second one, I only have a y. I don't have a multiplier. So it's easier to use that one. So I'm going to rewrite the equation. Y plus 5x equals 40. That was the original equation. I'm going to plug in a 5 for the x. So I get y plus 5 times 5. I'm going to put parentheses around it. Equals 40. Y plus 25, that's multiplication, equals 40. I'm going to subtract 25 from both sides. So notice I'm just following the steps, what we normally do. I'm going to subtract it. So, of course, these cancel. Y equals 15. So my two answers for x and y are 5 and 15. So that's how we solve one using elimination.